then, like I said, I'm going to try to start big and then bring it down into the network piece, what I'm here to talk about. So, get a definition of what is the Internet of Things. I think a good overview is three things that you need to remember. Sensors and actuators, which we just heard about from Monet. The connectivity piece, and then the people in the process, which is the result of what you're trying to do ultimately with the Internet of Things. So look at the sensors and actuators as the digital nervous system that measures anything: position, presence, proximity, motion, velocity, temperature, humidity, electricity, levels, acceleration, speed, light, sound, vibration, pressure, flow. I mean, anything you put a sensor on, pretty much measure these days. The connectivity is how you digitize that and place it onto a network, which would be either a wired network, RFID, near-field communication, Zigbee, Z-Wave, Bluetooth, Wi-Fi, low-power wide area networks, which is a term that if you haven't heard, I would encourage you to do some research on. And then, of course, cellular, which is why I'm here. And then the end result is the people and processes. So you combine that data into systems, and you enable better decision-making in the physical world, which transportation, patient monitoring, precision agriculture, utilities, smart grid, HVAC, finances, government, security, consumer health, obviously, smart homes is a big one. So this is kind of a simple picture of what I just explained. You have on the side there the devices, the sensors, and the network. You converge that into a platform, and then the output is your applications, your optimized operations, what you're trying to essentially sell to your end user. So simple, right? Not really. This is an ugly slide, but it's meant to be, I call it the IoT Stack. I look at IoT as a system of layers, and so there's many layers to the system, and I'm going to drill down a little bit, but you have to look at IoT as a system of layers. So we have the physical world, which involves the sensors, the power, things like that. We have the business world. How are you going to monetize your IoT solutions? How are you going to license it? How are you going to market it? That whole aspect of IoT. You have the user experience, so how your user is going to interact with it on their phone, on a device, on a bracelet, on a thermostat. You have the market, so what market are you going to go after? How are you going to look at your business from a market perspective? And then our section, obviously why we're here, is the tech space, or the tech layer, what I call it. So I just kind of zoomed into that piece, but even within the technology layer, you have the security and the data, you have the cloud services, you have the framework, the value-added applications, system applications, you have the software, all within that technology layer. You know, what cloud type application are you going to use? ThingWorx, something like that. IBM has a cloud solution. Amazon has a cloud solution, all geared around IoT. So we want to drill down to just a little bit more into just the network piece. So you look at IoT as a huge pie. The network piece that I'm talking about is just a tiny, tiny sliver of the IoT system. But it's very important, as you heard. How are you going to connect your devices? What kind of transport are they going to ride over? And again, you have those options. Maybe simplify it a little bit. Again, so connecting the Internet of Things, or the Internet of Everything, requires this wireless connectivity. You can do it your personal area network, local area network, such as Wi-Fi, or a wide area network, which includes cellular, obviously. So I wanted to start with, I'm going to get into why cellular and how that applies, but first I wanted to kind of answer the question, why not cellular? Why wouldn't you use cellular? And I think you can combine these. You can combine personal area networks, local area networks with cellular. But there is instances where if you have Wi-Fi, like a Vivint type security solution, and they have in-home Wi-Fi, you don't need. Why would you need cellular unless it's as a backup solution, or you know, a redundant option in case the Wi-Fi goes out? Wearables is another one where, you know, if you have a bracelet or a fallen and I can't get up solution, or a Fitbit, something like that, 99 out of 100 times you're going to have a Bluetooth connection. You're not going to need to pair that device via cellular, because it's going to be a local, it's going to be on your person. The modules might be too expensive. So cellular modules today, $30, plus or minus. I mean, if you need an LTE module that's backwards compatible to 3G to 2G, you're going to talk $50+. So if you're building a wireless bracelet, a wearable that your target price is $99, you're not going to put a third of your cost into buying a wireless module. Battery and power requirements, we're getting there, but there may be too much battery consumption. You may not have power supply access to even get to where you won't be able to use cellular. And in coverage, I think cellular is probably the most ubiquitous coverage you can get, but there's still remote areas in Montana where you're not going to find cellular coverage unless you build your own network. So things to consider. Why would you use cellular? Again, the coverage is ubiquitous. I mean, between CDMA and GSM, there's 2.7 billion connections worldwide. I mean, the tower, the infrastructure, everything's already in place. It's highly reliable, especially in the world of IoT, where you're just trying to connect bits of data. You're just trying to send little transports of data. You don't need, it's not like maybe you think your cell phone isn't reliable because you can't carry a call for 2 hours on the highway with it disconnecting. But in the IoT world, it just needs to connect for 10 seconds to send GPS coordinates or temperature data or whatever, and then it can disconnect and keep trying again in 10 minutes or an hour or whenever you want. So in that instance, the infrastructure in place, unless there's a fiber cut at a tower, it's going to be highly reliable. Security, it already has robust security. Lots of credit card solutions and things like that already ride over cellular in that environment. High performance, if you need the high data speeds like you do on your phone, it's there. And again, the ecosystem is mature. I mean, it's already in place. So you don't have to do the LP WAN space where they're still building those networks and that infrastructure. I think it has a place, but it's not in place yet, and it's not ubiquitous. So I hope that makes sense. And to the future, I had a bunch of slides on this. I just took one, but I wish I would have put more in now. But we're looking at, there's new advances using LTE technology. So think today, low power IoT solutions are going to probably use a 2G Verizon, Sprint, AT&T network. We're kind of leapfrogging because that infrastructure is in place. 3G, and we're moving to LTE, which today, like now, it is expensive. The modules are kind of expensive. As he said previously, they're not very efficient. The battery drain is pretty high. But there's new protocols coming out. Release 13 of the 3GPP standard is coming out later this year, which means that, I'll try to explain this as well as I can. So you have a Qualcomm chip in your phone that maxes out at 100 megs, likely for streaming Netflix, whatever you need to do on your phone to download applications. Not necessarily efficient for IoT solutions, where you're just, again, looking for low power, long battery life, and low bits of data. So we're in the process of building modules that, Telit and those guys are in the process of building modules that work more efficiently on our LTE network. So think about a max on a cell phone of 100 megs. We're building chips specifically for IoT that max out at like 1 meg or 2 meg, which makes the battery life more efficient. I mean, you can squeeze 10 years out of these modules. It makes them cheaper. They don't have as much radios, antennas, things like that in place. So we're looking at getting to like the $10 to $20 range for a cellular module in the next year or two versus 30, 40, 50. Perfect for IoT. And all the cellular carriers are doing this. All the major module manufacturers are building Category 1, Category 0, or as this references it, Category M modules. So if you're building a product and you're looking at cellular, talk to me or start doing some research on what that's going to look like in the future, next year to year and a half to 2 years. Again, it's necessary. We have the spectrum to do it. It just needs to be more efficient, which is what we're working on. So just to kind of close and just get to the really bare bones of if you're building an IoT product or you're trying to connect an IoT solution, the 3 stages that you're going to kind of want to consider that we help consult in, make those connections, is obviously the planning and initial assessment. So you're going to want to decide what sensors you need, what you're trying to monitor. from my perspective, you're going to want to decide if you need to embed a module, like are you going to build a product with a module in it? Can you get by with, like he had, with just a gateway, like a black box that's able to be placed in the field, already certified to ride on a carrier like Sprint or Verizon? Or there's a middle ground where there's socket modems that you can build a board. The socket modem will already be certified from somebody like a Multitech or a Eurotech. You don't have to go through necessarily the design and certification of your modem. They've already done that work. You just have to design your board around it. So that's kind of the initial stages. What's your budget? Can you afford to buy all those modules? What's your schedule? Do you need to get to market in 2 months? Then yeah, a Monet sensor solution with a gateway is probably the way to go. Are you looking to scale to 20, 30, 50,000 widgets out in the field of your product? Then maybe put in the initial investment to design your own board, get wholesale rates on those modules, get it certified on carriers like Sprint and Verizon, and deploy it that way. Or look at doing both, starting with the gateway and building towards a connected, certified product. So then you get into the design phase, so you have to consider, do you have the resources in-house to design your solution from a hardware perspective, from a software perspective? Do you need to bring in a consultant to do that for 3 months and pay them the required fee? I work with Boulder Engineering Studios in obviously Boulder, Colorado, who does a lot of design for my customers in terms of their board, antenna, battery. A lot of the IoT entrepreneurial spirit will be like have an idea, and even the software part is done, but as far as the hardware, how we need to design it, the form factor, stuff like that, maybe isn't their expertise. So do you need to bring in a consultant to do that? Paperwork, you're going to have to go through FCC paperwork with Sprint or Verizon or whatever carrier you're going to ride that solution on. You're going to need software and firmware support for your solution, so we make the connections with like the Sierra Wirelesses or the Telet or whoever you choose for your modem. They can help with the software and firmware support. Pre-testing, we have engineers in Atlanta, engineers in Kansas City and Seattle who help you do the pre-lab testing. So prior to getting into the lab, we'll take your device, run a bunch of commands, make sure it's hitting the network, make sure the device is performing as you want it to on the network. And we'll obviously support pilot units. So you want to get some units out in the field before actually paying for them or get them on customers' hands. We'll test that for a 3 to 6 month period prior to certification. So then eventually you're going to need to get certified with FCC, PTCRB certification, carrier certification with someone like Sprint or Verizon or AT&T. And then your RF and antenna is going to have to be accurate. It's going to have to meet the requirements that are laid out by us and the FCC. And then you launch your product. So that was quick, but I'm still 2 minutes over because we started late. So I'm open to questions. I hope that made sense in terms of where the network piece fits into the IoT structure. I'm happy to talk more about kind of where cellular fits into that, but yeah.
So as I was mentioning earlier, the infrastructure is going to change, inevitably. So as you're designing these products and building these products, are you going to have to kind of future-proof them? You're going to have to kind of think ahead as, what is the next 2 or 3 years going to hold? And will my product, really last to that point? Or am I going to need to start sort of...
Yeah. So from a network perspective or a carrier perspective, you'll pick the modules or the modems that you design in your product. Like Telet, for example, they have version, like a 2G version, 3G version. Now they have the LTE advanced version. It's all the same form factor, so it's not going to require a new board design. But as 2G, so I have smart utility companies who are built with the 2G version of Telet. And they're guaranteed through 2023, so they're set for the next 7 to 8 years. But they're already in design phase of bringing in, when a product comes in, you may as well put that new LTE advanced module in it. You don't have to redesign your board from our perspective. So the module manufacturers, the U-Bloxes, Gemaltos, Sierras, they understand that, they make it easy. But yeah, it does involve, if you're a legacy AT&T GSM 2G that's sunsetting next year, you are required to bring in all your products, retrofit them with newer redeploy them, so. All right, thank you. Thanks for sticking around.